Essay 65, Meaningless Relativity, a long essay. During the heyday of relativity, Einstein published a short book entitled The Meaning of Relativity, which tried to explain the subject in words. It is doubtful whether this book helped anyone to understand the subject, and there were many subsequent attempts to explain it in words. They just made the dogma foggier. The literature is saturated with bellowing about how Einstein explained the perihelion advance of Mercury and the deflection of light by the sun. As a matter of fact, he did neither. As a byproduct of my research in the past decade, I have had occasion to study Einstein's work in great detail and have found numerous errors in it. Up until 9 or 10 years ago, I had not studied general relativity, being a chemist by training. I did not assume that it was correct. I simply had not studied it. I had read books that were supposed to explain it, the best being by Pais, when I was at the University of North Carolina, Charlotte. However, I found that explanations in words inhibited understanding, so I tended to leave these books aside. Physics is saturated with dogma. The most rational subject is in fact the most irrational. This type of problem comes from poor historical scholarship and poor understanding of fundamentals. It is always claimed that Newton explained the three Keplerian laws of orbits with an inverse square law called universal gravitation. He did no such thing. My ancestor John Aubrey could have told you that in the 17th century. In the online brief lives, anyone can see that it was Robert Hooke who discovered that law. When the mathematics are carefully worked out, the inverse square law does not explain the existence of orbits at all, because it is a law of attraction. An orbiting object cannot stay in orbit if there is only a force of attraction. There must be a counterbalancing force of repulsion. Common sense. In the foggy dogma or fogma, this is the centrifugal force which regrettably does not exist in Newtonian dynamics. So Newton did not explain orbits at all, and he did not discover the inverse square law. The strangest thing is that everyone seems to know this and still carry on chanting fogma. That is human nature. Everyone who has ridden a bike or driven a car knows that the outward force is real enough, but it does not appear in Newtonian dynamics. It is in fact due to torsion of spacetime. The centrifugal force, as it is labelled, does not come from a centrifugal potential energy as it should. The centrifugal potential energy is really the angle-dependent part of the kinetic energy of a free particle moving around a plane, the rotational kinetic energy of a free particle. However, the fact that a free particle does not move in a straight line means by Newton's first law that it has to be acted upon by an external force that must come from a potential energy by definition. However, the rotational kinetic energy is part of that of a free particle, not acted upon by an external force. There is a diametric self-contradiction. A free particle is not acted on by a force, but a force is needed to keep it rotating in a plane. It is free and at the same time not free. In the Newtonian dynamics of a particle moving in a straight line, there can only be translational kinetic energy. The free particle cannot move in an ellipse, for example, without a force being present, but this force is not present and is contrived artificially. In the fogma, This rotational kinetic energy is incorrectly called a potential energy, and that is that we have magically effective potential energy. The basic problem is that Newtonian dynamics deals only with straight lines, not with motions of orbits. Coriolis attempted to cure this problem in 1835 or so, but the explanation is again artificial. The real explanation for orbits is that they are generated by the torsion of spacetime itself, and torsion is something that Einstein never considered. I found out recently that if I just differentiated the functional equation of the ellipse, the observed orbit of a planet, to an extant approximation, the inverse square law for force is obtained, with its negative sign indicating attraction, but there is nothing to counterbalance the attraction. The functional equation of the ellipse is the dependence of the radial vector on the angle, and the radial vector, twice differentiated, is the force divided by the mass of the planet. So what is always known in the dogma as an inverse square law of attraction is merely a re-expression of the equation of the ellipse. There is nothing to prove that there is an attraction or gravitation. These are anthropomorphic concepts. There is nothing to prove that there is an outward force. All that we are left with is an observation that the orbit is an ellipse. I suspect that this is what Newton really did. He used the techniques of his times to differentiate the ellipse twice to find an inverse square law. Newton's greatest contribution, in my opinion, is mathematical. The inference of differentiation and integration, which he called fluxions. When Hooke first drew Newton's attention to the problem, Newton certainly did not get the right answer. He thought the ellipse was due to an inverse R law. There is no reason to doubt John Aubrey in his classic Brief Lives. The dogmatic idea of a universal law of gravitational attraction arose from a coincidence described as follows. Using cylindrical polar coordinates in a plane, consider the function of an ellipse, r as a function of theta, where r and theta are the coordinates. Differentiate the position vector r twice with respect to time using the correct rules for differentiation in this system of coordinates. The result is a negative valued linear acceleration vector inversely proportional to r squared and directed along the radial vector. The proportionality constant between this acceleration and the inverse square of r is made up of constants of the ellipse. These are the right magnitude, half magnitude, and the ellipticity. Now apply the rule known as Newton's second law, a rule which merely defines the concept of force, which first occurs in Kepler's writings as being linear acceleration multiplied by a mass m, and which is not an inference based on data as in the usual meaning of law in physics. Differentiating the ellipse twice, therefore, produces a force that is negative valued, directed only along the radial unit vector, and which is inversely proportional to r squared. In so doing, the equivalence of inertial and gravitational mass m has been assumed. It has been assumed that m is the same in Newton's second law and his law of attraction, first inferred by Hooke from the work of Kepler. If the ellipse is assumed to be the orbit of m around m, then Newton's inverse square law is the force needed to maintain this motion indefinitely, or more accurately, produced by this motion. The radial vector is the line joining m and m. Note carefully that there is only one negative valued acceleration and only one force. There is no centrifugal force and no centrifugal acceleration. By experimental observation, the force in the laboratory between a static mass m and a static mass m is the same inverse square law with proportionality constant mmg, where g is known as Newton's constant. This is, however, pure coincidence. If the ellipse is made to precess, the force law becomes a sum of terms, one an inverse square law in R, the other an inverse cubed law. For galaxies, the force law is again different and wholly different from an inverse square law. There is no universal force of gravitation. Even worse for the dogmatist is that the negative sign of the force of attraction between static M and static M in the laboratory is merely a convention. If an apple of mass m drops to the ground, the dogma claims that it is due to the negative valued force of attraction exerted by the Earth of mass m. The negative sign of the force obtained by differentiating the ellipse is a mathematical property of the ellipse, more accurately a geometrical property intrinsic to the ellipse itself. The negative sign does not originate in the same source. The two phenomena, elliptical orbit and apple falling to the ground, are different. Therefore, the force between M and M of an elliptical orbit is not a force of attraction as in the dogma. If it were, M would fall into M, contrary to observation. The true source of the negative valued acceleration of the ellipse is simply the ellipse and nothing else. The ellipse may be described as a Cartan tetrad, and the spacetime torsion due to the ellipse evaluated by the first Cartan structure equation of differential geometry. The origin of the elliptical orbit is one kind of spacetime torsion. The origin of the central force between static apple and static M Earth is another entirely different kind of spacetime torsion. As described already, the dogma asserts that an elliptical orbit is a balance of a negative valued force of attraction and a centrifugal force of repulsion. Neither force exists. The former is a property of the elliptical tetrad, and its negative sign does not denote attraction, an anthropomorphic concept. The centrifugal force of repulsion is confused in the Newtonian dogma with the rotational kinetic energy. The latter is merely another definition. It comes from the use of the work integral and the Newtonian definition that force is mass multiplied by acceleration. It is easy to see with a little thought that all kinds of confusion have crept into physics since the 17th century. It is not surprising that general relativity has collapsed like a pack of cards. There is no purpose in obliging the student to reiterate dogma known to be incorrect or completely confused. A reform in physics education is long overdue. So, from the very beginning, Einstein set out to correct dogma. Einstein's theory in the solar system is a tiny correction of Newton's theory, which does not explain orbits at all. It is not possible to correct something that does not explain anything. Yet this is Einsteinian general relativity, claimed to explain nothing with ever-increasing precision at suitably astronomical expense. Outside the solar system and such objects as the whirlpool galaxy, Einstein's theory does not begin to explain the velocity curve of that whirlpool galaxy. It fails hopelessly, and so does Newton's theory. The dogmatists introduced more useless dogma, dark matter, and dark indeed. In the last decade, I discovered that the existence of a whirlpool galaxy is due again to spacetime torsion, which throws the stars outwards in their observed spirals. In the solar system, the spacetime torsion throws the planets into a precessing ellipse. There is no gravitation and no force of attraction, which is precisely the conclusion found by differentiating an elliptical orbit of the solar system and just explained. Motions and dynamics are due to torsional motions of space-time itself. So how did Einstein's dogma become so entrenched? I have no doubt that there is merit in Einstein's work in relativity, merit in its basic and ancient idea that physics is geometry, but a lot of it went wrong very early on, and in order to see this with clarity, a little accurate history is needed. The first steps towards the idea that physics is geometry were made by the ancient peoples such as the Greeks, who had the idea that geometry is an expression of perfection and therefore beauty. The proportions of the Parthenon were worked out according to this idea, and a flaw in the construction was put there so as not to offend the gods. Only the gods could know perfection. The kind of geometry developed by thinkers such as Euclid, a corruption of his real name, is known as geometry in space, for example a two-dimensional or three-dimensional space. Physics is automatically an expression of geometry because quantities of physics, such as vectors, are expressions of geometry. Newton wrote his Principia entirely in terms of geometry. This is a kind of relativity in space. Naturally, an object moves forward at a given speed with respect to another, and that means that the second object is moving backward at the same speed with respect to the first. This observation is made whenever a car starts to move backwards, when one is sitting in a bus, until one realizes that the bus is moving forward and the car is stationary. This kind of relativity is one of those things that are accepted as obvious until there arrives the need to change the entirely obvious, and this is how great discoveries are made. End of part 1.